In this video, we're going to continue looking at key properties to consider in exploratory data analysis. And in particular, we're going to focus now on scope, temporality, and faithfulness. So what do we mean by scope and temporality? Scope is really a sense of whether or not your data captures the range of information that you need in order to answer your research question of interest. So will your data be enough to answer your question? Example, if you're interested in studying crime in California, but you only have crime data for one city in California. In that case, it's a pretty obvious solution where you could try to collect more data, or if that's not possible, you may need to change the research question. Also, we may come into cases where your data actually covers more than the scope of what you're interested in. And in that case, you're going to need to filter out the data. But then sometimes you end up with too few data points to be able to answer the research question you're interested in. So we'll talk more about that when we're looking at sampling in the future. And then we'll think about how your data is situated in time. Does it cover the right time frame based on your question of interest? And that leads us to the idea of temporality. So key ideas in temporality is when was the data collected? Is there any periodicity? Do you see any patterns? And then oftentimes you're going to get date and time fields that are inherent or part of your data. And a big part of the EDA is identifying, is this date indicative of when an event happened, or when data was collected, or when data was entered into a database? And then time depends on where. So time zones can become a very important piece in your data analysis if you're incorporating temporality, because you need to make sure that you are consistent with how you're interpreting data collected in different time zones. And so the datetime Python library will be very helpful in converting, for example, data that's loaded as a string into a datetime format. And then Pandas has, similar to the str accessor that we looked at with string data, it has DT accessors, which are going to be really helpful for manipulating all kinds of date and time data. Let's do a brief exploration of the date-time functionality in Pandas. And so I'm going to have you go to our exploratory data analysis Jupyter notebook and scroll down to temporality. Okay, so we're just going to do a little bit. You're going to do more of this in your assignment. In particular, one of your assignments, you'll be looking at calls for service for the Berkeley Police Department. And so here is the first few rows of some of that data. And notice there's 3 columns that have dates and times. One of them is this event date, one of them is event time, and then another one's further over in the in database, right here, in database date. So event date does stand for the date when the event took place, when the call was entered. Event time is the time of day, and then in DB dates, the date it was actually recorded in the database. You notice that if we look at the time or the type of these, they're stored as strings, so we can look at that real quick, and then we can convert them. So let's just do the type of them first. So I can see each of those dates are stored as strings. That's the object here. And so if I want to convert, for example, the event date, you can call PD _ to date time, and then you put in the column you want. Now, this is going to give a warning in this case just to let you know that it may not interpret the event date correctly. So you want to make sure, eyeballing it, that it's actually correct. This first one should be April 4th, 2021. And I do in fact get that here. So that's great. But if you weren't able to get the exact right format, sometimes, what's a month is actually a day and vice versa, then you can actually be fancier in what you put into this to date time and specify the exact format that the date is coming in. But now I have this, and now notice we can use the DT accessor on this column. So if I call this to give me the month, it's going to give me the month for each row here. I can also do the day of the week, which date is on. This is, in this case, right here, and then the minimum values to see if there's any suspicious looking dates. And so, oops, let's actually do that there. Let's check the minimum. So I could do calls, event, date, and then do min. Okay, so that's good because the minimum that I have is December 17th, 2020. This also allows me to sort by date, which we can also see as consistent. If I do sort values.head, it gives me the earliest, and if I did .tail, I'd see the latest dates that I have here. So we are going to play around with this data set more in an assignment, but this was just to give you a quick little taste and intro to the DT accessor. If you see strange null values, so actually January 1st, 1970 is a key null value time. That's actually like in Unix system time. Oh, yeah, actually that is my next slide. Let me show you. In Unix time, it was measured in seconds since January 1st, 1970. That's the UTC time. So that was kind of our time zero. And if you see that data or that date showing up in your data, you may want to be wary because it's likely just a missing value. Same idea with 1900. That can also happen. All right, and what else? So faithfulness is now going to be a lot of the gut checks you need to do to make sure that the data is consistent with your own understanding of the scope and your own understanding of how the data should behave. So do you have unrealistic or incorrect values? Dates are a good place to look. Ranges of values are a good place to look. You don't want like negative values for things that can't be negative. You don't want locations that don't exist. Misspelling of names is key. If you're grouping on names, oftentimes you might have the same person entered in there twice, just misspelled. Or if you have any really unusual outliers, these are things that you want to just investigate to make sure that it's not an issue with your data itself. There are obvious dependencies you can check. If you have information like age and birthday, you can do quick checks to make sure those are consistent. And then for data that was entered by hand, again, we talked about misspelling of names, but you could also look at spelling errors and other fields that may have been impacted. And then finally, keep an eye out for data falsification. That is something that will show up, unfortunately. And so being aware of that in the EDA process is a good place to catch it. So some signs that your data may not be faithful. The first thing you might look for is truncated data. The early versions of Microsoft Excel would actually have limits on the number of rows. And so if you see that your number of rows is that exact number, 65,536, that should be a red flag that this likely was not the full data set and it just got truncated in an earlier file. Spelling errors, duplicated records, units not specified or inconsistent, time zone inconsistencies are all other things that you may need to play around with. And there are ways to address these easily in pandas, as long as you catch them before you start trying to make any conclusions from your data. These are all good flags or things to be looking for when you see entries like this in your data. So sometimes you're going to, if you are missing data, there are some options and commonly used practices as how to address it. One practice is to drop the records with the missing values. I will say this is probably the most commonly used method, but I want to caution you because this can induce biases unintentionally, depending on what you're trying to do with the data. So I would be very wary and be very careful before you just throw away data values that are missing. Something that's a little safer to do is to keep them as not a null, NaN, and then that way anytime you're doing some analysis, that data will still be in there. You'll get, if you're doing plots, you'll be able to see where the NaN values are, what the issues are, and that'll help you keep in mind that that's data that's missing. A third common practice is to do what's called imputation, where you replace a missing value with some other value. And there's a way that you can decide what to replace it with. So one common replacement is to replace with the mean of a given variable. And that's going to be usually okay when your distribution, and we're going to talk more about distributions in general, but if this is your variable, you can think of this is letting me know most of the variable here occurs right around the center point, and the mean will also be right here. So that will be a reasonable guess for any missing values, and it also then won't alter your statistics for that variable as much. It'll leave your mean the same. Another alternative is to do what's called the median. So the median is the middle value of all of the values for a given variable. And so in this case, when it's symmetric, the mean will be equal to the median in this first picture. But a case where they're not the same, and we're going to cover this more in the future, are skewed distributions, something like this, where your median may be somewhere around here, your middle value that's splitting the area exactly into half on the left versus the right, whereas your mean is going to be shifted a little bit more because of this long tail. And we're going to get into all this theory in future videos, but again, just letting you know that that's an option for something you may use when you're doing imputation. And mode is another statistic that can be used. That's your most commonly occurring value in a given distribution. And that's going to be useful when you know from the context of the data that it's frequently going to be one specific value. Those are three common ones. There's more sophisticated imputation and interpolation techniques that, zero. Let's not forget zero. I would caution you against doing this unless it makes sense in the context of the data. So sometimes missing data really can just be replaced with zero because it's measuring something that really could be zero. Other strategies, these are out of the scope for this class, but helpful in case you want to look into more alternatives. One of them is called hot deck imputation, where you replace just with a random value. Another one's called regression imputation, where you can replace using a model. And a third is called multiple imputation, where you can replace with multiple random values. So again, just some things to let you search on your own if you're interested. In our next video, we're going to actually go through this process with some real data. And in this process, we'll experiment with these three different options of dropping records versus keeping as NaN versus imputation.